Hello everyone. Today I am using ArcGIS and the Spider IDE to extract the elevation from the digital elevation model. For that, I have already opened my prepared a zip file of my station, and this is my DEM file. You can see it here. Here we can get elevation value from here of all the data present in the DEM file, but as we are working through different time, we need to have a elevation value of certain points, and we can't extract it from the GIS without manually. Generally, manually we can prepare it by opening Excel and typing, identifying the point and manually taking it from these values and preparing it on the Excel. But today we are going to do it in the Python with a very simple script of the Python, so that we can easily can prepare our file of elevation of this point easily, or extract it from this point easily. You can see it. Every point has its pixel value that defines the elevation. You can prepare it by manually by doing this, but it is little bit time consuming. So for many more data, but for that today we are going to dealing it with the Python. So I am moving to Python now. Spider IDE. You can see it here. Now first of all we have to import GeoPandas. Sorry, I haven't prepared my module first. So for that we have to go to our working folder. We have to select our working folder here. Only selecting our working folder, then we can create a new module. You can name it extracting of elevation values, and you can generally save it. Now this is our working folder. You can see it here. Now we are heading to scripting. Import GeoPandas is GPD, and you have to import another one for the raster or the DEM file library, raster IO library. After this, you can generally, we have to make the read the station shape file first. So for that now I have put the comments there. I have given a variable name station. You can see here. You have to copy path. I have to request it for by typing variable R, and you have copy path, this path, Control C, and you have to paste it here. And after this, what you have to do is you have to put the shape file. You have to put the shape file that you have prepared from the ArcGIS, and I am copying this file by Control C, pasting it here, Control V. After this, you have to close your commands here, path, and you can simply run it. You can see it here, we have no error. Now we can proceed ahead. After that, we can see in our variable explorer here, we have a data of 15. I have prepared a 15 points that we can extract our elevation from it, and our geometry of our station is 0.5. We are going to getting the elevation value of these points geometry, and I have taken 15 points, and for that now we can here see this is our geodata geopandas frame, geopanda geodata frame, and now you can see it here. I am going to put here, I am going to use this station name is station name in calculating the elevation by using this Coulomb, this Coulomb latitude and the longitude value. You can get it very easily after my command. Here you can give it an name equal to row, and we have to put a command here. You can generally use the name of the column that we are going to use, and we are using latitude and longitude of the raster file to locate our point and calculate our elevation values from it. You can see it. And y value gives the latitude and the x value gives the longitude. It is a little bit tricky. You can get it. And now you might get little bit confused. So for that I am on activating these commands here to show you. Now you can see it here. You can simply type print row, and you can see you can simply run it, and you can see simply see we have just punctuation error here. I have typed the capitalized F here, so that we have get error here in syntax error. So I have make it. Now you can see what I have done is that I have printed a row. That means I will make you clarify about it. You can see it. It will print every row. That means this 0 0 station 1 0 point. In this way it will go through all these 15 points. So I have created this loop here. It will later on help us to calculate our elevational value according to our points. So I am this. After this you will get, you can see our command is right, so it will run without error. So you can see again our longitude and the latitude value that we have created according to our x and the y point here. And now we are heading towards reading the DEM file, so that we can get the elevational value from that DEM file here. Reading the DEM raster IO library. You can simply type DEM equal to raster dot open request it. You have to copy our path. Is we have make read of zip file. We have doing the same thing here. We are going to doing the same thing here. So I am going to copy my file, TIFF file here from the variable explorer, and the my TIFF file is this. And I am copying it by Ctrl C. You can general type Ctrl C, and you have to put a, you have to close your path by apostrophe. After that you can simply go through row or column. In what way we are going to dealing in this is we have created a row column xy longitude latitudinal value here, so that you can see it here. When we zoom it very closely, we can see every pixel of it particular size. For that you can go to source. I will show you. You can see it here. It is made up of many pixel cells made of size 30 meter. You can see it here. It has made up of lots of combination of pixel value. You can see it by zooming it. You can get it in the. You can get it here. This is, you can change. You can feel the change here if you see it closely. Every pixel value is made up of different cell, and each cell has a different elevation, or it can have same elevation according to its value according to its latitude, longitude, elevation. You can get it. Now for that I am going to specify or make my commands to go through every cell so that it will read every pixel data and help us to get our data from data point. You can see Control C, Control V, comma, Control C, comma, Control V. After this, what does it will do is it create a row or column variable that calculates the data according to our index. It will provide a run for all our 15 points. It will search our 15 points elevation data in our every cell of our raster data here, so that it will go through every longitude latitudinal value of the pixel cell and helps to helps to extract our elevational values from the raster cell. As we know, the digital elevation model is the as its name suggests us that it is the data of elevation model which helps us to calculate the different spatial analysis. So that here what I am going to do is I am going to read my DEM data here. Now you can see after this I am going to read my DEM data here and creating a variable as DEM data naming variable. After this I am going to make it read DEM dot read and I am giving it 1 and closing it. After this you can print out elevational values as I mentioned. The elevation of, you can simply do it here and you can simply print, you can simply put it space here or plus. You don't need to leave a space here and plus out this DEM data. Control C, Control V. You can see it here and this row comma column info. This will help us to read row column info, latitude and longitude info. And we need a string value here. We need a string value here. It is a number value, but it need a string function here is str. so that it will read out this DEM data. So after this, what I am going to do is we have this value in meters, so I am defining unit here. Every punctuation marks matter here in programming. So I am closing it. After this, you can simply run your commands here. You can see it here. I forget to mention our name here, so I am going to copy my name variable here. Control C, and I am doing it, pasting it here simply. After this, you can simply run it. Now it will print us our data or the information according to our wish. You can see it here. You can see there the elevation of station 1 515 meter, the elevation of station 2 175 meter, the elevation of station 3 785 meter. You can simply see it. Or if you inactive this command here, we can get more appropriate information and we can analyze it very simply. So I am running it again. You can see it here. We get it very simply here. Elevation of every of 15 points that I have created in my DEM file. Here you can see it. You can identify if our work is going good or if we are going good process, as we are right or wrong, moving towards the wrong direction. You can see it by labeling feature. Go to property, go to symbology, and no label. I'm sorry. Now here we have to put it name, as I have assigned name is station 1, station 2. And you can simply click OK and you can check what is our station 1 value. You can check this is our station 1 value and it has data of 549. You can see it here, and as we have created, it is 515 meter. You can see it. It has extract our information, and you can similarly see the station 2 value here. $174, and you can see station 2 value 174, very close to it. And you can check it similarly, we can get it accurately. So I am not moving more than this for all station is the video length get increased here. So after that I am creating a column of elevation value in my creating an empty column for the elevation value in my station data frame. In this data frame I am creating here a elevational value. For it you can simply get it here, create empty column for elevation values, and for that you can simply do stations dot, and you have to give it a name, elevation, and you have to equal to 0 simply, and you can run it here, and you can see it in our geodata geopandas frame. It will add an elevation column here, empty column here. So how can we get these values on our column? We can get it by typing a command here. You can simply go through. First of all, I am adding comment over it for adding the values of elevation. You can simply get it after it now, and I am adding a comment here. Station. You can simply get it, and elevation, and I am going to you have to look at here what this elevation. So I am adding, sorry, not there. We have to edit here. After this, we have to locate our index. It will what it will do is that in elevation value it will locate the row or name of the station where we have to add the elevation value. As per this index provide every points will come it in serially or regularly respectively. You can get it. Now for that we have to make a read this row, DEM and column. You can simply copy it, Ctrl C, and you can here fill your column by simply pasting it, and you can run your value. After this, you can simply run it. And you can see it in the variable explorer here. You can get it here, our elevation value from our column here, elevation column, and we can get it station 1 column 515, station 2 175, station 3 785. And after this we can save this value in the Excel tool. For that you can, I am going to adding a comment over here, saving our data in CSV format, and simply you can type elevations variable that we have created equal to stations, and what we have to do is we have to choose our column which we want to keep in our Excel file. So I am choosing my name file and the elevation file. That means we'll have this column and this column in our elevation file, Excel file that we have created here. So without delaying or without extending video length, I am doing it. Simply go through just name variable or the name column that we are going to put it in our file, and we can simply get elevations here. After this, we have to just elevations dot to CSV, and we have to type our name of our file here, and I am doing it as a elevation info. I am giving it a name as elevation info of topography, or we can simply save it as topographic elevation. You can simply topographic elevation, and with this you can see dot, we have to provide a format of our Excel file too. After this, we can simply run it and we can get it in our working folder, and we have created our gear. Now we can get it in our working folder. I am showing you that. Our working folder is that, and we can see it here. We have created our information here, and by this way you can create you can extract the elevation of a very huge large number of stations or the point by this process. So it is useful for handling the larger data, to extract the elevational value of larger data. So we have done our work here. So with this, I am gonna end my video here. Thank you.